ton of refrigeration is roughly equivalent to 12,000 BTU per hour, often abbreviated as BTA, and not simply 12,000 BTU. What this means is that a 1-ton air conditioner has the capacity to remove 12,000 BTU of heat from a designated space within a single hour. The concept of a ton in refrigeration originates from the amount of heat required to melt 1 ton, which is 2,000 pounds, of ice in a 24-hour period. It's a measure of cooling capacity. It is important to understand that beta is a rate of heat transfer indicating how much heat is moved over a period of time, specifically an hour. Now, to convert BTU to watts, you must multiply the BTU value by 0.2931. The reason for this conversion factor is based on the definition of a BTU and a watt. 1 BTU is defined as the amount of energy required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. On the other hand, a watt is a unit of power, representing the rate at which energy is used or generated. 1 BTU is equivalent to approximately 1055 joules, and 1 watt is defined as 1 joule per second. When you perform the conversion from BTU per hour to watts, you are essentially converting from a measure of heat energy to a measure of electrical power. So, multiplying the BTU value by 0.2931 effectively converts BTU per hour to watts. For example, if you have an appliance that produces 5,000 BTU per hour, you would multiply 5,000 by 0.2931 to get the equivalent power in watts, which is 1465.5 watts. It is important to note that there is sometimes confusion between BTU per hour, kilowatts, and tons of refrigeration. Firstly, a kilowatt is a unit of power equal to 1000 watts. Secondly, to convert kilowatts to BTU per hour, you multiply the kilowatt value by approximately 3412. Thirdly, as mentioned earlier, 1 ton of refrigeration is equal to 12,000 BTU per hour. These conversions are commonly used in HVAC system design and analysis to ensure that the cooling or heating equipment is appropriately sized for the specific application. Using the correct conversion factors is essential for accurate calculations and efficient system performance. In summary, a ton of refrigeration equals 12,000 BTU per hour, not just 12,000 BTU. To convert BTU to watts, simply multiply the BTU value by 0.2931. Remember to always use the correct units and conversion factors to ensure accurate results when dealing with thermal and electrical energy calculations. The reason this is so critically important is that, for example, if you were to size an air conditioning system for your home or business, you need to be able to accurately assess the amount of heat that needs to be removed from the space. This is typically measured in BTU per hour. Once you know the beta requirement, you can select an air conditioning system with the appropriate cooling capacity, usually measured in tons. If you underestimate the beta requirement, the air conditioning system may not be able to adequately cool the space. On the other hand, if you overestimate the beta requirement, you may end up with an oversized air conditioning system which can be less efficient and more costly to operate. Similarly, when working with electrical equipment, such as heaters or appliances, it is important to understand the relationship between BTU and watts. Heaters are often rated in watts, indicating the amount of electrical power they consume. If you need to determine the heat output of a heater in BTU per hour, you can use the conversion factor of 0.2931. This information can be useful for calculating the energy consumption of the heater and estimating its impact on your energy bill. It's also critical to consider the efficiency of the equipment you're using. For example, some air conditioning systems are more energy efficient than others, meaning they can remove the same amount of heat while consuming less electrical power. The efficiency of an air conditioning system is typically measured by its seasonal energy efficiency ratio, also known as SEER. A higher SEER rating indicates a more efficient system. When selecting an air conditioning system, it's important to consider both the cooling capacity in tons and the energy efficiency in SEER to ensure you're getting a system that meets your cooling needs while minimizing energy consumption. Another area where these conversions are useful is in understanding the energy content of fuels. For example, natural gas is often sold by the therm, which is a unit of heat energy equal to 100,000 BTU. If you want to compare the cost of natural gas to the cost of electricity, you need to convert the energy content of natural gas to a common unit, such as kilowatt-hours. This can be done by using the conversion factors described earlier. It is important to remember that these conversions are approximate, and the exact values may vary depending on the specific conditions. However, they provide a useful way to compare different forms of energy and to make informed decisions about energy use. Furthermore, when designing or troubleshooting electrical systems, understanding the relationship between BTU and watts is essential for ensuring safety and preventing equipment damage. For example, if you're installing a new electrical circuit to power a heater, you need to make sure that the circuit is properly sized to handle the load. This involves calculating the total wattage of the heater and selecting a circuit breaker and wiring with sufficient capacity. If this circuit is undersized, it could overheat and potentially cause a fire. Therefore, it's important to consult with a qualified electrician to ensure that your electrical system is safe and meets all applicable codes. These codes and standards are often based on the National Electrical Code, also known as NEC, which provides detailed requirements for electrical installations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Adhering to the NEC is essential for ensuring the safety of electrical systems and preventing electrical hazards. In addition to safety, understanding the relationship between BTU and watts is also important for optimizing energy efficiency and reducing energy costs. By using energy-efficient equipment and implementing energy conservation measures, you can significantly reduce your energy consumption and lower your utility bills. For example, you can install a programmable thermostat to automatically adjust the temperature in your home or business based on occupancy and time of day. You can also insulate your walls and ceilings to reduce heat loss in the winter and heat gain in the summer. By taking these steps, you can create a more comfortable and energy-efficient environment. In conclusion, understanding the relationship between tons of refrigeration, BTUs, and watts is essential for a wide range of applications, from HVAC system design to electrical system installation to energy management. By using the correct conversion factors and following best practices, you can ensure the safety, efficiency, and sustainability of your energy use. And remember, 1 ton of refrigeration is 12,000 BTU per hour, and to convert BTU to watts, multiply by 0.2931. Furthermore, it's also important to consider the power factor of electrical loads when calculating energy consumption. Power factor is a measure of how effectively electrical power is being used. A power factor of 1 indicates that all of the electrical power is being used to do useful work, while a power factor of less than 1 indicates that some of the electrical power is being wasted. Many electrical loads, such as motors and transformers, have a power factor of less than 1. This means that they draw more current than they need to do the same amount of work. This excess current can increase energy losses in the electrical system and lead to higher energy bills. To improve power factor correction capacitors can be installed. These capacitors supply reactive power to the electrical system, which reduces the amount of current that is drawn from the utility grid. Improving power factor can significantly reduce energy costs and improve the overall efficiency of the electrical system. In addition to power factor, it's also important to consider the voltage and current ratings of electrical equipment. Voltage is a measure of the electrical potential difference between 2 points, while current is a measure of the flow of electrical charge. Electrical equipment is designed to operate at specific voltage and current ratings. Operating equipment outside of its rated voltage and current can damage the equipment and create a safety hazard. Therefore, it's important to ensure that the voltage and current supplied to electrical equipment are within the specified limits. Also note that different countries and regions may use different voltage standards. For example, in North America, the standard voltage for residential electrical systems is 120 volts, while in Europe, the standard voltage is 230 volts. When using electrical equipment from a different country, it's important to use a voltage converter or adapter to ensure that the equipment is operating at the correct voltage. In addition to voltage, the frequency of the electrical power supply can also vary. In North America, the standard frequency is 60 Hz, while in Europe, the standard frequency is 50 Hz. Some electrical equipment is designed to operate at both 50 Hz and 60 Hz, while other equipment is designed to operate at only one frequency. Operating equipment at the wrong frequency can damage the equipment and create a safety hazard. When using electrical equipment from a different country, it's important to check the frequency rating of the equipment and use a frequency converter if necessary.